John Philip is currently Emeritus Professor at Department of Physics, CUSAT. Before joining the physics family at CUSAT, Professor John Philip served as Associate Director at Indira Gandhi Center for Atomic Research, IG Kalpakkam, and was also Professor at Homi Bhabha National Institute. He is an elected Fellow of National Academy of Sciences. Professor John Philip he earned his PhD from IIT Madras, and he has a large year of postdoctoral experience in world-renowned institutes, including CNRS and University of Hull, UK. He's a renowned researcher in the field of ferrofluid. In fact, the largest ever BNRS prospective research grant has been awarded to Professor John Philip. It has a amount of 5.6 crore, and he's a pioneer in the field of ferrofluid research. He has more than 340 research papers in his credit in leading international journals, and also holds 6 patents. He has more than, that is, he has a citation of more than 23,000 and an H index of 73. He has been consistently listed among world's 2% scientists by Stanford University since 2019. I think it has been 6 or 7 years he has been in the list. He has many prestigious awards in his credit, including Science and Technology Excellence Award, which was presented by Dr. APJ Abdul Kalam, our former president, INS Medal, NDT Man Year of the Award, MRSI Gold Medal, Ron Holscher Award, which is by British Institute of NDT, Distinguished Faculty Award, and Homi Bhabha Science and Technology Award. It is in fact the highest distinction of the Department of Atomic Energy. He also serves as editor of many scientific international journals, including he's editor-in-chief of Journal of Nanofluids. And with immense pleasure, Academy of Physics Teachers Kerala welcome you, sir, for the technical session as part of our annual general body meeting. Professor John Philip, now the floor is yours. Thank you, sir.
Thank you, Dr. Asha, for your kind introduction, and good afternoon to everyone. It's really a pleasure and privilege to be here today to discuss a topic that is not only timely, but also deeply relevant to the world we live in and work. Teaching in the age of artificial intelligence. That's the actual title, because I've chosen physics because this is attended by physics teachers. But the content will be useful for all teachers who are teaching different disciplines. So thank you, Asha, once again for inviting me to deliver this lecture. So when I was a student, one of the biggest challenges was finding the right book in the library to clarify doubts. But today, students don't necessarily look for the books. They ask AI. It's a reality today. AI can serve as a personal tutor for students, a teaching assistant for us, teachers, and a powerful collaborator for researchers. And for ordinary people, AI can simply simplify everyday life, from healthcare and banking to transportation and public services. So the real question is no longer, will AI change our future? The question is, how well are we prepared to shape that future? So let me begin with a little journey back in time. So you see 2 images. These are photographs of 2 of my presentations from the 1990s. Looking at them today, I realized that I was not only giving presentations, I was unknowingly documenting the evolution of technology and lecturing or teaching. In those days, presentation meant transparencies, physical slides, overhead projectors, handwritten notes. If the projector refused to cooperate, the presenter had to become the projector. That was the situation in those days. The technology has changed. We moved from transparencies to PowerPoint and from physical slides to digital presentations, from printed notes to electronic documents, and eventually classroom to online teaching like the one we are witnessing today. Over the past 3 decades, I have personally witnessed this remarkable transformation. I'm sure some of the senior teachers attending this too must have witnessed this. Technology has continuously changed how we teach, how students learn, and how knowledge is accessed. There is one thing common in these two photographs. The slides have changed, the technology has changed, but the presenter or the teacher is still standing in front of the audience. By the way, this presentation, the left one, was made in Shanghai, China, by a third-year physics research scholar from IIT Madras, my younger self. And the right one is, sorry, and the right one is my first presentation in IGCAR after joining as a scientist. And this trip to Shanghai was fully supported by International Physics Association, both travel as well as the stay for 5 days in a hotel. So for me, these photographs are more than a memory. It's a reminder of the opportunities that physics can open up. That's why I'm showing these slides here. If we keep learning, if we keep exploring, and most importantly, keep trying. This could be a valuable advice for young students, along with the inspiring motivational stories that highlight the opportunities and possibilities available to the students. So this is the technological evolution I have witnessed from 1990s. I'm sure many of you have witnessed, at least Jera sir, I know that he must have witnessed this. So this is the remarkable journey we have witnessed during the last 3 decades or so. Technology has always evolved, but notice something interesting. The goals hasn't changed. Only the tools have changed. The computers have gone from room-sized boxes to AI-powered laptops. Thankfully, they have become smarter and lighter today. The photography has moved from film camera to digital camera and smartphone cameras. So the mantra on those days were don't waste the film. And today we take 200 selfies and delete 199. So mobile phones were once used mainly to make phone calls. But today, making phone call is probably the least used feature in a smartphone. Televisions have evolved from bulky CRT boxes to ultra-thin smart TVs that are sometimes thinner than the instruction manuals. The cassette players disappeared, and it's all about streaming today. And today's students have probably never seen a pencil used to rewind the cassettes. And letters have become instant messages, and floppy disks have disappeared into the cloud, or we use pen drives. In fact, many students think the save icon, which is shown here, was invented by Microsoft, not realizing that it is the actual floppy disk many of us have used. I have used it during my PhD days. So the lesson is simple here. Technology keeps changing, but it doesn't eliminate the need. It transforms how we meet it. And that brings us to education. Just as calculators, computers, or internet did not eliminate teaching, learning, or replace the workforce. So at least some of the teachers may fear that AI may replace teachers. I don't think so. Because AI won't eliminate teachers, it will transform how we teach and how students learn. This is the change we're expecting. Now, to understand why AI is transforming education, let us take a quick journey through the technological revolutions that shaped human civilization. We began with the stone, bronze, and iron ages, and finally, somewhere in 60s, silicon age, mastering materials which are used in various applications. The first industrial revolution happened in 1784 that introduced steam power to mechanization. The machines began replacing muscle. The second industrial revolution brought electricity and mass production. We learned to scale up things, the production. And the third industrial revolution introduced electronics, computers, automations, where machines began processing information. And today, Industry 4 connects computers, cloud computing, robotics, big data, AI, machine learning, and many more things. The machines are moving beyond calculations to learning, reorganizing patterns, and making decisions. That is what it is happening in Industry 4. And Industry 5 points further towards human creativity working together with the intelligent machines. So there is a remarkable progression we can see here. Materials, energy, information, and intelligence. So each stage was powered by advances in physics. That's the most interesting point we should note. From mechanics and thermodynamics to electromagnetism, quantum mechanics, and semiconductor. Semiconductor is the one which enabled all these electronic gadgets that we have today. So in the late 90s and early 2000, when I began my research, nanotechnology was one of the science great buzzwords. The massive investment by governments, industries, and other institutions reflected the belief that nanotechnology would drive the new technological revolution. And in fact, it did. Transformed electronics, medicines, energy, catalysis, sensors, advanced materials, all these fields, nanotechnology has given a big contribution. The smarter and thinner devices that we see today is the outcome of nanotechnology. We have reached somewhere around 2 nanometer technology. That is going to come in the next few years from now. 7 is what it is used in the smartphones and other devices. But Intel came up with the 2 nanometer technology 2 years ago, and that's what it is going to be used in the coming years. So then, after nanotechnology, the AI came. It has not replaced nanotechnology. Rather, it has become a powerful layer across every discipline, including nanoscience. It is accelerating materials and drug discovery, scientific data analysis, experimental design, education, and industry in a big way. Having witnessed the rise of nanotechnology, I now find myself watching another revolution unfold. From the era when nano was the buzzword to an era where AI is the buzzword today. Perhaps the most exciting question is not which one will win, but what happens when the power of nanotechnology and AI come together. That may be where some of the most exciting science of future will emerge. So before I move to the A part of my lecture, let me make a small confession. When I decided to give this lecture, that's the one Dr. Asha wanted. I give her 3 titles. So I realized that I had quite a few questions about myself. So I thought, rather than pretending that I already had all the answers of AI, let me use this opportunity to find some clarity. So I spent a few days to go through what is AI. So the next few slides are essentially my own journey of trying to understand AI, what it is, how it works, what it can do, the capability, where it can go wrong, and most importantly, what all this means for us as teachers and for our students. Some of you may have already know much of this, perhaps even far more than I do now. If so, please bear with me. Consider the next few slides as my attempt to understand this subject better rather than a lesson on AI. So how AI works, how search-enabled AI improve reliability, that is what it is shown here. You ask a question, a search in the website, it compares multiple sources. I will come back to the sources, websites, etc. in the coming slides. And it look for agreement, it generate answer and provide citations. This is what it does. And what are the sources it is using? It uses all kinds of resources. For example, it uses books, textbooks. It uses research papers which are available to it, public websites, encyclopedia, open source code, technical documentation, images, diagram, public video, audio scripts, public online discussion. All these things are searched. So what AI does with this information? AI does not memorize documents like a library. Instead, it learns the language pattern, the relationship between concepts, reasoning patterns, common facts, writing styles, problem-solving approaches. These are the things which is looked at. So the important limitations of AI is AI does not automatically know whether every source is correct. If incorrect information appears frequently during training of AI may reproduce it. So the situation is like garbage in. It gets garbages from the web and it gives garbages out. So that's what it happens in AI. So you know that many of the sources, they're not reviewed or edited by experts. Wikipedia, anybody can put information in Wikipedia. And similarly, many information which are available in the websites are not reviewed. Now, how reliable the information you get from AI? Does AI know which sources are reliable? The answer is partly. It knows now. Because the modern AI learns that certain kinds of writing tend to be more trustworthy. For example, it considers university textbook, peer-reviewed journals, government publications, established encyclopedia, scientific organizations. These are the websites it considers. The information available in these sites are considered to be trustworthy. And the less reliable anonymous blogs, clickbait websites, conspiracy pages, spam, contradictory web pages, etc. are considered less reliable. So it tries to take information from the trustworthy sources. But still, the question is, why does AI still make mistakes? Because AI does not perform fact checking the way we do. Instead, it predicts what is most likely to come next. So sometimes what can happen is incorrect information appears frequently. The correct information is rare. Some of the searches, it may not find correct information, maybe one or two, and that may be wrong. The question is ambiguous. If your question is ambiguous, it's a problem. AI simply generate plausible sounding answers. Sometimes it is called AI hallucination. So for physicists like us, we never accept a measurement without estimating its uncertainty. So the messages, take-home messages, likewise what we do in the case of measurement, we should never accept an AI-generated answer without checking its accuracy. Again, AI accuracy depends strongly on the type of questions, the models, whether it can search, and how the answer is evaluated. For basic and widely established facts, AI often highly reliable, although verification is still advisable. For standard concepts and calculation, the familiar scientific concepts and routine calculations, AI is usually reliable. But occasionally, errors can still occur. You can test that with known concept. Sometimes you may find incorrect answers. For highly specialized on newly emerging research, AI can be considerably less reliable, but because the information may be limited, incomplete, or rapidly changing. And it has also limited resources in the case of journals and publications. If the question is vague or open to multiple interpretation, AI may make assumptions and produce less reliable answer. When the information is rare, poorly documented, and difficult to retrieve, AI may generate plausible sounding but incorrect information. That's what I said, hallucination. As the number of factual claims increases, there are more opportunities for individual errors, inconsistencies, and unsupported statement. So the take-home message here is, again, for more complex, specialized, ambiguous, or information-heavy questions, AI-generated answers must be verified before it is used. So AI does not decide truth the way scientists do. It predicts the most probable answer from the pattern it has learned. So AI is an extraordinary assistant. It's an accepted fact, but it is not an unquestionable authority. And the teacher's role is no longer to compete with AI, but to teach students how to verify, evaluate, think critically about what AI produces. This naturally leads to an important education principle: trust but verify, and use AI to accelerate learning, not to replace our thinking. Now, what are the challenges for the teachers in the age of artificial intelligence? So, of course, I've already discussed this. It is very important to verify the content, checking the accuracy before it is used in the class. And the same advice needs to be given to the students. And you have to redesign assignments. If you are giving assignments, they can simply copy from AI. Okay? The questions that promote thinking is what it is needed to avoid plagiarism. And the third one is ensuring academic integrity. And it should be able to, the teachers should be able to distinguish the students' work from a output. And the next one is the changing the role of teachers. I have already said AI has become a personal tutor for students. So the role of teachers are changing from lecturer to mentor and facilitator. And the changing role and the keeping pace of AI, it is very important. AI models, LLP is, trained with a lot of resources. So we need to keep pace of the AI, continuously update teaching strategies as AI evolves. The information overload is the next one. The guide students to distinguish knowledge from noise. A lot of information available. They're confused which one is right, which one is wrong. So this needs to be, students should develop a capability to distinguish knowledge from noise. And next one is ethical and responsible use of AI. Teach students to use AI responsibly, transparently, critically, and acknowledge. When it is used, they have to acknowledge. If they generate an essay, if they generate input for an assignment, or if you generate an image, the acknowledgement is a must. Teaching future skill is another important thing. This is what all industries or all institutions are required. Students with the critical thinking, creativity, and problem solving. So this part we need to take care. And preserving curiosity is the most important thing. Inspire students to ask better questions, but teachers, because AI can answer questions, sometimes wrongly, but many a times it gives correct answer, maybe 90 or 99% right answers it may give. But 1% can be wrong, or even fraction of that could be wrong. So the curiosity that only teachers can inspire among students. So these are the challenges for the teachers in this era. Let us now look at another major transformation in science. We are entering the age of interdisciplinary science. For centuries, we neatly divided science into physics, chemistry, biology, mathematics, engineering, and so on. Today, the physicists may use lasers and quantum mechanics to probe living cells. So it's a collaboration between physicists and biologists. A chemist may design materials for batteries, solar cells, and quantum computers. Again, collaboration is required. Chemistry, materials, and with other disciplines. The biologists may rely on mathematics, statistics, and AI to understand genomic data. Massive biological data sets are to be analyzed using AI and mathematical tools. The mathematicians model climate change, pandemic, and population dynamics. Again, mathematicians can collaborate with many branches of science and engineering today. So while computer scientists use machine learning to discover drugs, predict protein, design new material, again, you can see the synergy among the computer scientists with medical and other researchers. So the boundaries between disciplines are rapidly disappearing. Now, nanotechnology you take is perhaps one of the best examples for the interdisciplinary science. It brings together physics, chemistry, biology, engineering, medicines, and computer, almost every branch of science and engineering, often to solve the same problem at the same scale. We're now seeing convergence taken even further. Probably you must have read the recent news report. Stanford University researchers have demonstrated how generative AI can help design entirely new bacteriophages. Bacteriophages, viruses that specifically target antibiotic resistant bacteria. It's not harmful to us. So they were able to model it and produce this bacteriophage. So AI is no longer merely analyzing scientific information. It's not merely generating images or answering our questions. It is increasingly helping scientists design new biological systems. So what does this mean for us as physics teachers? That's the interesting question. We should prepare our students to become better scientists, able to communicate across disciplines, use tools from different fields, and approach problems from multiple perspectives. That is what exactly it is required in the coming days. And this is especially important in the age of artificial intelligence. Science of future will be increasingly interdisciplinary. And therefore, the education of the future must be interdisciplinary too. Now, let us see something that every one of us carry in our pocket every day, a smartphone. We can call this a portable museum of science. Why a portable museum? Because inside this small device, we have an extraordinary collection of physics, chemistry, material science, mathematics, engineering, computer science, and now artificial intelligence. So everything is generated, and I've created an image using AI. The display brings together optics, electromagnetism, semiconductor, quantum physics. The battery, electrochemistry, and material science. The processor, the physics of billions of semiconductor devices. The camera, optics and sensors. GPS combines electromagnetic waves, satellites, precision timing, atomic clocks. That's relativity. And the information reaches us through optical fiber, where light travels through tiny glass fibers using physics of refraction and total internal reflection. And finally, increasingly, there is AI and machine learning in every feature and app that we use today. So this is much more than a phone. It is a laboratory, it is a computer, it is a camera, it's a communication system, and a remarkable collection of science all in one pocket. And this gives a message. What is the message? Physics is not confined to the textbook. This is the message you need to convey to the student. It is already present almost everything we see, touch, and use. It is present everywhere. Our challenge is to make that invisible physics visible and exciting. This is what it is required today. So try to make it visible, the physics visible and exciting to the students. Tell them that, these are the applications. This is very important at a time when there is a steady decline in the interest in science. Now, we often think science as separate compartments: physics, chemistry, biology, mathematics, computer science. So I have already told it is, these boundaries are getting blurred or disappearing. The next wonder material may not come from a physicist alone. That is the situation today. It's a fact. As a researcher, I can tell very honestly. That's why in all labs, all institutions of physics, you have collaboration among people from different disciplines. So the next discovery may not be coming from a physicist, but through a collaboration between chemists who create it, a computer scientist who explore millions of possibilities through codes, and a biologist who understand its interaction with the living cells. This is an important message for all of us. Our colleagues in other departments are not our competitors. Earlier it was like that. Ideally, they must be our collaborators if you want to be successful. The great challenges of tomorrow, there are many challenges in the energy sector, climate change, health, new materials, quantum technologies, artificial intelligence. All these problems can be solved only through collaborative works. So we must encourage our students to collaborate with other disciplines, because often the most exciting discoveries happen not within the discipline, but at the boundaries between disciplines. Now, we have seen how science is changing. Disciplines are converging, how collaboration is becoming essential, and AI is transforming how we access and process knowledge. All these things I have covered. So as teachers, we must ask, in this rapidly changing world, what qualities should we develop for our students? Technology will change, tools will change, even knowledge will evolve, but some qualities will remain fundamentals. The first and foremost thing is curiosity, the courage to ask questions why, and the question what others may overlook. This is the first and foremost quality. Even AI, you have to ask questions. Questions are not generated. Of course, you can do that, but the important questions that can lead to discoveries, has to come from you. And the second most important quality is integrity, the honesty to accept nature's answer, even when it contradicts the experiment's expectations. If an experiment disagrees with our theory, we should question the theory, not the experiment. if experiment is not artifact. Okay, so the third most important quality is perseverance, the determination to continue despite failed experiment, rejected papers, or disappointing results. Science is rarely a straight line. Many failures become step towards discovery. I'll give some examples in the coming slide. The, the fourth one is creativity, that is the ability to see connections where others see unrelated facts, and to ask, what if I look at this differently? And the last one I have already covered, the wisdom to recognize emergent trends for which you need collaborations. So perhaps our responsibility is not simply to give students more knowledge, but to nurture the curiosity to question, the integrity to be truthful, and the perseverance to continue despite failures, and creativity to imagine, and wisdom to collaborate. So A may become an extraordinarily powerful, but these are the qualities that make scientists good or excellent. We've just talked about 5 qualities that matter. But if I had to choose the one quality from which scientific discovery begins, I would choose curiosity. Every major discovery begins with someone asking a question that others may have overlooked. I will give few examples. Consider Michael Faraday. He had worked with a relatively simple experimental tool with no formal education. But his extraordinary curiosity led him to ask, if electricity can produce magnetism, can magnetism produce electricity? This question, his answer led to the discovery of electromagnetic induction, which underpins much of modern electrical technology. Again, a cartoon generated using AI. So all these technologies we have today because of a curious question from someone who used very simple experimental tool. Now, closer to our home, we have a great example, Sir C.V. Raman. Raman was fascinated by the deep blue color of the Mediterranean Sea during his voyage from England to India in a duck in 1921. Instead of simply admiring it like other tourists or other co-passengers, he asked a question, why is this sea blue? That curiosity ultimately led to the discovery of Raman effect, now fundamental to spectroscopy across science and technology. It's a molecular fingerprint in almost every discipline. So the two scientists, two simple questions. I give only two, but I have many. Okay, we can give many examples. And the consequences of these questions that change the world. That is what we have seen in these two cases. So as teachers, we never know which question from one of our students might become tomorrow's breakthrough. And in the age of AI, this matters even more. AI can provide an answer in second, but the questions worth asking still to come from us. So curiosity can change the world. So let's take this idea of curiosity a step further. We often think a great scientist is someone who sees what nobody has seen before. But the fact is, science is thinking what nobody else has thought about what everyone has seen. History is full of such examples. I just listed a few of them. Everyone had seen lighting, but someone asked, could this electricity be controlled? This has opened the way to our understanding of electromagnetism. Everyone had seen bird flying, but someone asked the question, what makes flight possible, leading to aerodynamics and modern aviation. Everyone had seen apple fall, but Newton asked the question, could the same force pull the apple also hold the moon in the orbit? Thus, the question transformed our understanding of gravity. And the curiosity to see invisible things led to the development of microscope. Then the invisible world became visible, transforming biology and medicine. We looked at the stars and then asked, what are they? How do they shine? Giving us modern astronomy and astrophysics. So the observation gives us phenomena. Curiosity gives us question, and imagination turns that question into science. Let me give you one more beautiful example of how a simple why led to innovations. Look at this lotus leaf. We all know that water simply rolls off from its surface. But someone asked seemingly simple question, why does the lotus leaf remain dry? It is not wetting the surface. That question led to scientists to investigate somewhere in 78 only by a botanist. He took a layer, he made a replica and placed it under an electron microscope. This surface structure, the combination of surface chemistry and the micro nanoscale features he discovered led to the design of non-wetting surfaces like the one. Now we can generate such super hydrophobic surfaces or any kinds of surfaces, metals, semiconductor, glass, even fabrics you can create. And what you see are real images. So this kind of surfaces are created and they have plenty of applications. So today this idea has applications in self-cleaning materials, window glasses. You don't have to clean it. Water repellent coatings, anti-fouling surfaces, ships and hulls it is used, and many other technologies where it is used. And these are the applications. It has tremendous applications in corrosion resistance. For example, what you see is a super hydrophobic coated surface, steel surface, and uncoated surface immersed in salt water after 60 days. So once again, a simple why can take us from observing nature to creating new technology. That's the message I wanted to give from this slide. So I have another 10 minutes. Yeah. So nature has always been extraordinary material scientists. I'll give a few more examples. Look at the chameleon. It can change its appearance in response to its environment. It can sense the stimuli like vibrations. Touch me not is a plant. It can sense a stimulus and respond immediately. Scientists asked that questions. Can we make a material that can behave like this? It can sense a stimulus and respond. That curiosity led to development of smart and intelligent materials. Materials that can sense, respond, adapt, and self-repair. This kind of materials are developed. Recent years, it's not long ago, in recent last 2 decades, there are plenty of technologies. So that curiosity seeing the colors, the structural colors of chameleon or the butterflies and the touch me not plant led to the development of smart intelligent material. Material can sense a stimulus like temperature, light, pressure, electric field, magnetic field, and change their functional properties. There are plenty of examples. Today, these are finding applications in sensors, robotics, healthcare, aerospace, energy, adaptive technology. So, physicists, chemists, metallurgists, chemical engineers, mechanical engineers, all discipline, the people from different branches of science and engineering are working. What you see here is a shape memory alloy, which has wide range of applications. And we have also worked in this area, and you can have response stimuli emulsions we have made. It can detect defects in material, like the one you are seeing here. If there is a defect, it can be seen in the form of color changes. So there are examples, but I think I should restrict. I can skip this because another example is nacre, the hard materials we can, make it now using biomimetic. And structural colors we learn from butterflies. We can create, photonic crystals and many other technologies today using the structural colors that the butterflies are producing. And gecko is another beautiful example how curiosity is turning observations into technology. We've seen gecko climbing effortlessly on the walls and even walking up down. The question is, how does it do that? Scientists discovered this again in 90s and 2000. Scientists discovered that its feet has covered with millions of microscopic structures that is called settle. And these structures create a very strong adhesion through van der Waals forces. So once we understood the physics of this structure, gecko's feet, we began to ask the question, can we reproduce it? Yes, the scientists and engineers reproduce it. So gecko inspired advanced adhesives with potential applications in robotics, medical devices, manufacturing, climbing systems, and space technology are made today. So once again, observe nature, ask why, understand physics, and create something new. Probably this is the last example. Here is a beautiful example to how understanding nature leads to technology. We first understood nuclear fission, how heavy nucleus can split and release enormous energy. And that fundamental knowledge led to development of nuclear reactors and nuclear power. Now we look at the sun and discovered that the enormous energy comes from nuclear fission. Light nuclei combining and releasing energy. Today we are trying to reproduce the process here on Earth through fusion reaction. We have not yet succeeded, but it is sustained only for seconds or less than a minute in the reactors. So there are challenges, but the message is curiosity, fundamental understanding, discovery, and technology. So this is another example. Again, it's my field. Let me show a material that has been at my heart of my research for nearly 3 decades, ferrofluids. What makes them fascinating is that they bring together two seemingly different worlds. Magnetism of tiny particles and fluid mechanics. That's what you see here. They flow like an ordinary liquid, yet they can be controlled and shaped by magnetic field. You can see the videos here. The fluid motion is controlled purely by a magnetic field. That simple combination created remarkable phenomena and opened up applications in heat transfer, sensing, optics, energy, biomedical technologies. For me, product fluid are also beautiful examples of what we have discussed. When different areas of physics, chemistry, biology, engineering come together, completely new possibilities emerge. And there are plenty of applications for this fluid in almost all regions, which I told you just now. So the failure, again, a point about perseverance. Failure is part of research. Failure gives us better learning and it can lead to discovery. In research, often celebrate the final research, but we rarely see experiment that failed along the way. A failed experiment is not necessarily wasted effort. It tells us what does not work. And sometimes that is exactly what guides toward what will work. So I would like our students to remember failure is not the opposite of research. Failure is part of the process of research. And sometimes the failed experiment is the one that teaches us the most. We have example, for example, Thomas Edison. I skipped this. When he succeeded and demonstrated electric bulb, a journalist asked him, "You have failed 1,000 times. Don't you feel discouraged?" The answer was, "I have not failed. Have just found 1,000 ways to do days that do not work." So every failure brought one step closer to success to Thomas Edison. Another beautiful example is Alexander Fleming. He noticed a mold on bacterial culture when he came back from vacation. The question he asked, why are the bacteria dying? As per lab manual, he was supposed to throw this culture plate. But he asked this question that has led to the first, discovered the world's first antibiotic, penicillin. And accidental discoveries led to many innovations. For example, a melted chocolate bar in the pocket is what it led to the microwave oven. Unexpected glow is what it led to X-rays. Failed refrigerant experiment that led to Teflon. And 3M was trying to develop strong adhesive, but they found weak adhesive, and the inventor thrown it in the dustbin. But somebody found that it is useful for post-it notes. So the torch is now in our hand. So this is the end of my, probably the last slide. Every generation inherits the knowledge of the previous generation. It's like a relay of sports. But our responsibility is to carry it a little further. We have a lot of knowledge from the past. Perhaps one of our students will develop battery that power next century, or discover a life-saving medicine. We don't have medicines for many diseases, for example, cancer. Create a transformative algorithm and solve fusion problem. We are facing problem. We have been talking about room temperature superconductivity. Okay, so that is to be achieved. Make clean energy affordable or uncover the mystery of life and universe. And we don't know which student or teacher will do this. But as teachers, we have the privilege of helping them to believe that it could be done. And sometimes the student asks, where can physics takes me? So this is a challenge. This is for all the teachers. Some students may ask you, where can physics take me? And the answer is almost everywhere. That is what I listed here. Physics can lead them to fundamental research, teaching to space, nuclear science, quantum technology, AI, computing, photonics, medicines, nanotechnology, energy, advanced material. And these opportunities are no longer confined in the physics department. A physics graduate can become a scientist, engineer, data scientist, a researcher, entrepreneur, or international R&D researcher. So our message or your message to students should be simple. Physics does not narrow your future. It gives you a foundation from which you can explore the world. So looking at this photograph, you see, I've taken the photograph of 1990 and some recent pictures. Looking at these pictures, I realized that my journey of physics has been a journey not only through science, but also through people, places, and generation. From a young researcher in 1990 to where I'm today. The technology has changed enormously. The world of physics has changed, expanded, and I have had the privilege of learning, teaching, traveling, collaborating, and most importantly, working with generations of students and young scientists. But one thing has not changed: the curiosity, the desire to learn something new and to share it with others. That's why I'm here in CUSAT today. And perhaps that's the real journey of a teacher and a physicist. We carry the torch for a while and then pass it on to the next generation. Looking back, I realized physics gave me a far more opportunities than I could ever imagine as a student. And that time, I was not even aware of many doors that a career in physics could open up. As I gradually discovered those opportunities, I had the courage to explore them, and fortunately, many of those attempts turned into rewarding experiences and success. And today, I strongly believe we should not limit our students by what we know today. We should help them to discover the possibilities that they have not yet imagined. And I still continue my exploration with the curiosity to learn the changes since 1990. So finally, I would like to conclude with one of my favorite stories attributed to Rabindranath Tagore. A simple story, but with a message that I believe is deeply relevant to all of us. It's the story of the sun and the candle. When the sun went down in the evening, he asked everyone on earth, who will take up my responsibility of providing light? No one replied. A candle in the log cabin answered, my lord, I cannot light up the whole universe as you do, but I will try to light up this small room. This is the answer given by candle. The sun can illuminate the entire world, and no candle can ever compete with it. But when darkness surrounds a small room or a little cabin, the candle can still provide light that is needed. And I think there is a beautiful lesson here for all of us. We may not be able to illuminate the whole world, but we can brighten this small corner entrusted to us. Our classrooms, our students, our colleagues, our community. We should come forward and offer whatever light we can. As teachers, our responsibility is not necessarily to create the greatest scientist in the world. Sometimes it is simply to light up a small spark in one student, a spark of curiosity, confidence, and hope. So let us be like the handle, useful when needed, generous with our light, faithful to our responsibility, and humble enough to remember that our light is part of a much larger world. We may not be the sun, but we can always be someone's candle. And I've done the job of the candle today. So thank you very much. And my sincere thanks to Dr. Asha and Department of Physics, CUSAT, and AI tools for assistance, which helped me a lot to improve my presentations and generate images. And thank you for all for your kind attention. Thank you.
Thank you very much. Please.
Yeah, thank you very much, sir. It was a very wonderful talk and an inspiring one too. I hope many young teachers are here and they will get inspired by this. They will, as you said, they will take their torch forward. Thank you so much.
Any questions?
Yeah, we can have some questions, if any. We have started. I know that we have started at 3 o'clock.
Yeah, I've exceeded.
No, not at all, sir.
10 minutes.
Yeah,
I tried to finish.
Yeah, it was really inspiring to all we teachers, and we are understanding the importance of making the students curious and also to make them think differently on natural phenomena, natural observations, and also to be not
So
fully.
I think we have a question from Satya.
Yeah, please. Please ask, sir.
Hello, sir. Myself, Ayappan Satya, a student of Dr. Philip.
Go ahead.
Yeah.
Go ahead.
So with all these existing tools of AI and a lot of information is available, but the quality of research is somehow it's not that balance is not there. Have you seen that, or what do you think about this? What is your opinion on that?
No, AI, for example, AI can accelerate or help you to expedite your process. For example, the literature search, you can do it quickly and you can organize things very fast. Earlier, you take probably a month to organize many things. Such organizers, you can do it very quickly. And simple calculations, you can do it quickly. And the data analysis, you can do it if you feed your data. So basically, it can augment your capabilities. And I have given you an example. This news came a few days ago. The bacteriophage is discovered. Okay.
Yeah.
By Stanford University. They say that AI, because of AI, they could accelerate. Otherwise, it could have taken many more years. So this is what you are expecting. But, many things, for example, in our own research, if you just, you try to generate something, you find a lot of mistakes. The reasons I have already stated. The reasons are, how it is trained, how AI is trained. AI is not trained properly in many domains. Okay, that process is going on. And some of the AI is capable of doing certain things better as compared to other AIs. So there are many. We hear about Chat GPT or Gemini, Perplexity, but there are many, and they're specialized. Such tools will come in the coming years. And what you could do, for example, when I started my research, or when you started research with me, probably 15 years back, you would have spent 6 months or 8 months to get all the information from literature on magnetic particles, how they are synthesized, what is the role of different parameters on co-precipitations and other techniques. But this information your students can get in no time. So he should be able to start the research. When I started research, I spent almost 6 months to go to the library in in IIT Madras to get the abstract. Each that 200-page abstract book we open, and every day we scan it to see what are the electro-optic properties of liquid crystals or the liquids. And this information you get it in no time. So why you should take 5 years? I took 4 years to complete my PhD. And now if I do the same research now, I can do that in maybe 1 year or less. So research is accelerated. You can do things very fast. When I write a paper, I didn't have EndNote. I didn't have Mendeley. So I write 60 references, and each iteration, when it is corrected, I have to put this reference back in sequence. This can be done in no time. So,
yeah,
you don't understand? Okay.
Yeah,
so this is the beauty of AI. This is the beauty of internet. This is the beauty of the resources that we have today.
Thank you.
I think you are clear about it. So what you did in 5 years now can be done in 1 year if you spend that much time.
Sure.
And use the resources properly.
Okay. Thank you, sir.
Okay.
Nice evening. Bye.
Yes.
Any other questions? If there are no questions further, I request our treasurer, Shashidevan sir, to officially extend our vote of thanks to the resource person and also to this August gathering. Shashidevan sir.
Thank you. So let me first extend a very great thanks to sir. It was truly an inspiring talk when he touched from. There is a nice touch from his own research and his early research career to the latest technologies in AI. So I think the talk probably covered the aspects of technology, how it affects teaching, and where it stands now. So I think there is no more apt person than somebody who has seen that all. I don't think the young generation has seen many of the earlier part of it, I'm sure. I mean, for example, I have never used that kind of a presentation technique. I think most of us belongs to the computer era, where computer just started. So many thanks for sharing your views and the inspiring talk. John Phillips, are always a great pleasure to listen to you and to learn from you.
It's my pleasure.
So on behalf of the Academy, thank you very much for joining in this gathering. Thank you.
I also want to tell you something, because since this is an academy, and the science academies also give very good funding to promote science activities. And I used to go to this Tamil Nadu and Andhra Pradesh for conducting that kind of workshops. They give something like 1 to 2 lakhs for organizing 2 days program for promoting science program. In colleges, not in big university, but small colleges, it can be organized where the academy, you can invite a few faculty members and you can engage people. So that possibility, if you are interested, I can give you those details and you can explore. And that is one way you can promote science. And there is a decline of science among our students. And it's very important that we promote science activities in schools, colleges, and in small, towns and institutions, government colleges, and all such support can be obtained. Yeah.
Sure. Yeah. I hope the new committee will look into that proposal, and so I'm sure that we can all seek the help of sir in this regard. Yeah. So I also thank every member who is present in this gathering, and I hope that the new committee will take the activities forward and make physics great again in the state of Kerala and beyond. So എല്ലാവർക്കും ഒറ്റ വാക്കിൽ നന്ദി പറയുന്നു. എനിക്ക് തോന്നുന്നു വേറെ ഫർദർ പ്രൊസീഡിങ്സിലേക്ക് നമുക്ക് പിരിയാമെന്ന് തോന്നുന്നു. സന്തോഷ് സാർ.
Yeah, of course. President, if the president declares the meeting closed, it's fine.
So the new president.
Yeah, maybe Harish sir.
ശരി, നമ്മൾ ഇപ്പൊ 2 മണിക്കൂറിലധികമായി ഇന്ന് മീറ്റിംഗ് APT ആനുവൽ ജനറൽ ബോഡി